So now that you have learned what cryptographic hashes are, it's time for us to finally understand what that magical mathematical formula is all about. Remember that before a node on the Bitcoin network gets to add a block to the blockchain, it has to be the first node in the network to solve a very difficult mathematical formula. This activity satisfies the proof of work protocol, which is a measure that the Bitcoin network uses to avoid spamming and denial of service attacks. In this video, let us try to understand that formula. So what are the nodes trying to solve? In a nutshell, each node is taking an input and running it through a hashing algorithm in hopes of getting a specific output. As you learned from the last video, hashing algorithms are one-directional, so you cannot work backwards from the hashed output to determine the inputs. So the only way to get the desired output is to hash millions of different inputs until you get the right answer. Faster processors can do this activity faster, and that is why, as I explained in earlier videos, it is virtually impossible for you to mine for Bitcoin with your PC today, because you'll never be able to solve this problem faster than the specialized miners in the network. The Bitcoin proof of work algorithm requires the following parameters: a service string, which includes a version field, a hash of a previous block, a Merkle tree, which is a hash of all transactions, current time, and difficulty. It also includes a nonce, which is an arbitrary number, and a counter. So approximately every 10 minutes, each node assembles all these parameters into a 160-character input. And this input is run through some hashing algorithms in hopes of obtaining a 64-bit character output. There's no way of gaming the inputs to obtain that output. They just have to try as many different permutations as possible by incrementing the counter and nonce fields after each try. They're trying to obtain a 64-character output that has a certain number of leading zeros. The higher the difficulty, the higher the number of leading zeros. This is how the formula gets more difficult as more people join the network. The difficulty increases, and in turn, you're required to solve for a problem with more leading zeros, which makes it harder. Whichever node obtains this correct hashed output first adds their block to the blockchain.